Hello everyone and welcome to another episode of GDDV 106, Development Concepts. My name is Kasanis. Guys, we're moving along pretty well. We're moving into week 2 of GDDV 106, and we're actually doing not so bad here. All we've covered so far is the course introduction, so you know what I'm expecting, and we've taken a quick look at the Unity interface, and really it was a really brief look at Unity's interface. We're going to get to know that interface a lot better as we do practical exercises in this particular course. All right, today we're going to move on to the idea of C# scripting. We're going to do a complete intro to coding in C#. We're going to start off really slow with the idea of object-oriented programming in C#. All right, let's get started. Okay, so let's start off with an introduction to coding, and we're going to start off really simply. A lot of my students have never done coding before, so this is going to be their first look at coding. So I'm going to start off really slowly, and we're going to discuss what coding actually is. And in very simplistic terms, code is basically a human-readable language. That's what coding is for us. We're able to write in a language, and then afterwards our computer is able to either interpret or compile that language into computer-readable language, basically ones and zeros. So code generally, whether it's a scripting language or a compiled language, is a human-readable form of instructions for the computer that later on get converted in some way to be able to be used by the computer itself. We're going to be studying C#, and a lot of people question whether or not C# is a scripting language or a compiled language, and I don't know if it actually matters. I don't think it actually does. As far as C# is concerned, the operation of C# within Unity is fairly optimized, and anything you want to do within Unity, you can do with C# pretty well. So whether or not C# is a scripting language or a compiled language, it's actually both. It's compiled as well as interpreted later on by a virtual machine. So there's actually arguments over whether or not C# is a scripting language or a programming language, or compiled language. And you know what? It honestly doesn't really matter. Once you understand C#, you're going to be able to do anything you want to do inside of Unity. Once you understand the logic that goes in behind creating, the rest of it is syntax, meaning that once you understand what you want to do, you'll be able to then write code that'll do those things. You might not get the code right every single time. You might have errors in your writing, but once you get the hang of the logic, syntax, which is just basically how you write, the syntax is something entirely different. Now, once you understand the logic behind code, it's really easy to learn other languages as well. So that's the really important thing. Understand what you want to do, understand the logic behind what you want to do, and then go ahead and try and write the code. When you get the syntax wrong, you just go back and correct it. So let's go right away into Unity. We might as well not talk about this. Let's go right away into Unity and take a look at actually creating a script. Let's see what Unity gives us. All right? I'll see you guys in Unity. Okay guys, here we are inside of Unity, and I just want to show you right away that this time, rather than start a 3D project, I've started myself a 2D project. And the 2D project is pretty much identical to what we saw with the 3D project. Nothing's really changed as far as our interface is concerned or anything else. Really what's changed in opening up a 2D project is I've begun in 2D mode, so I'm only seeing my scene space right here in 2D, and rather than having a camera and a light source, my 2D game mode only has a camera. The camera itself has been put into a very specific form. It's an orthographic, but we're going to take a look at that in a much later date. But that's really the only difference. Everything else is the same. My project still has my silly sample scene name. It still has the same assets and packages that's been created for me by Unity. So everything else is kind of the same. So with that said, I want to take a look at let's take a first look at scripting now, a first look at your script. And I want to say it's important to note that the scripts that you write in Unity are components of game objects. And we haven't discussed the idea of game objects yet. But a game object is really an object that you can create inside of Unity that will get added into your hierarchy or into your scene or into your project. If I want to create a game object, I can go to game object, and I'm just going to create an empty one for now. We're going to get into much more detail about game objects at a later video, but for now I'm just going to create one so that you can see it. So right here I've got myself a game object, and over here in the inspector right now I can see what my game object includes. My game object currently includes the ability to name it, tag it, and put it onto a specific layer, and we'll discuss all of that later on. as well as this transform node. And the transform node allows me basically to move this object around in space. So right now there's nothing associated with this object. Let me just turn on a visual indicator for you. There we go, an icon. So right now, my icon indicates where my game object is, and it's basically changing this transform node. Know that every game object you create will have a transform node or something similar to a transform node that allows us to position it, rotate it, and scale it within the world. Now, below that, we see an add component button. And the add component button is where we take a basic game object like this and make it into a compound or a more complicated game object of some kind. We can add many different things to game objects, many different components to game objects. We can make it into a particle system. We can make it into a light. We can make it into a camera. In fact, if I click on the camera right now, the camera is a game object, like we saw before, with a name and a tag and a layer, as well as a transform node, and an additional node right here that defines this particular game object as a camera. This component right here is what makes our camera operate properly. In our blank game object, we don't actually have anything else. So the reason I'm telling you this is it's important to understand that any scripts that we write have to be attached to a game object in order to be able to do something. The scripts by themselves will not run unless they're associated with a game object and then put inside of the scene itself. Okay, so for now, let's just take a look at creating ourselves our very first script. In order to create a script inside of Unity, we're first going to go to our project. And just like we created the folders in the last episode, we can either right-click and say Create, and then find ourselves Script. C# script right here at the top. It took me a second to find it. Or else if you want to, you can go to the plus sign, and you can say C# script. As soon as you do so, it's going to be added into your project. And right now, it's going to take on this particular icon. And it's called a new behavior script. If we want to, we can rename it. So let's do so right now, just so we can identify what's happening when we rename it. I'm going to call this my script. Okay, once I've done so, I'm going to hit return, and it's going to automatically rename that particular asset to my script. Now, again, my script is not associated with any game object, so it's not going to do anything right now. If we take a look with my script selected, if we take a look in the inspector, we can see exactly what makes up this script currently. But rather than view it like this, I'm going to suggest you double click and launch Visual Studio. Okay guys, here we are inside of Visual Studio, and there's a couple things we're going to see right away. So Visual Studio is basically an editor. It's a script editor. There are a lot of different script editors available to you. You do not have to use Visual Studio in order to create your scripts for Unity. It does come packaged together, so I'd recommend doing so unless you want to go out and find yourself a different editor. But like I said, there are a lot of different choices as far as the editor itself is concerned. A couple things right away that you have to know. This is obviously the area that we're going to write our scripts in. The scripts that you have available will be across the top here in different tabs, and you can tab between those different scripts. File is going to allow you to save your stuff. And you know what I'm going to do right away? I'm going to go to Tools right away. Let's go to Tools. I'm going to make this a little bit bigger now that I'm thinking about it. I'm going to go to Tools. I'm going to go to Options. This is where you'll change the color theme, etc. But I'm going to Fonts and Colors. Let's make this a little bit bigger for you guys so you can see. Let's try 16. Okay. There, nice and big. It's going to be too big, but at least now you guys can see it. Anyway, so yeah, basically I went to Tools, and you can change everything in there if you want to change the colors, etc. So let's take a look at what we've got as far as our initial script is concerned. We've got lines that go from line 1 all the way down to line 18. That's where our code currently exists. You're going to find the numbering system along the side that tells you exactly where each line of code exists. Later on, if you've got an error, it will refer to a specific line of your code, and you'll be able to go directly to that line of code. So that's really, really important. You can turn that off, though. If you don't want to see the line numbers, you can absolutely turn it off. I leave it. At the very top of our script, we have something that says using systems.collection, using systems.collections.generic, and using Unity Engine. These top several lines, don't touch these top several lines of code, just leave them for now. Basically what they are links to libraries, and these libraries have additional code, pre-written code, that allow you to do other things, access other things. Later on, for example, when we're looking at UI, we will include lines like using unityengine.ui, and that's going to give us access to all the code that controls the UI system. So by including the appropriate lines at the top, the using rising lines at the top, you're going to have access to built-in existing code. Now below that, starting on line 5 and going all the way down to line 18, we've got something that says public class MyScript : mono behavior. And all the code in between is between this curly brace and this curly brace. Some people call it curly brackets, some people call it brace, some people call it curly braces. There are a lot of different names for this particular character right here. I'm probably going to call it different things. I'll call it a curly bracket or curly brace, I think, for the most part. What we can take a look at here is, this is the scope of a class. Now, we're going to talk about a class in just one second. But basically, with an object-oriented language like C#, everything, all of your code has to be included within a class. We created a script previously called MyScript, and that became the name of this particular class. You cannot change that. If you change MyScript here, it's going to mess everything up. So if I change the name of this, it's going to give me errors later on when it's looking for MyScript, and it's not going to be able to find this particular class. So make sure you do not touch this particular line right here. Okay? Leave that as it is. And like I said, all the code is between these two curly braces. If I want to see which brace is matched with which brace, I can simply click on the outside of the brace and it will highlight the paired braces. All right, so I can see these two are together. If I click here, I can see these two are together. If I click here, I can see these two are together. Obviously, it's very simplistic right now, but if you had, a million lines of code, it might become more difficult to find, or if you all had several things that were embedded within each other, it might be difficult to find out exactly where your braces match up. So what we've got here is a class. Public class MyScript. This mono behavior means that this script is based on the ideas of mono behavior. It inherits from mono behavior. Inside of my script, I've got several other lines of code: void start with brackets and then braces. And this is called a function. Start is called before the first frame of every update. Down here is void update. Update is also a function. So again, a function takes the form of void or some return type, whether or not it's public or private, update, and we're going to talk about this in far more detail later on. All we're doing right now is examining what code is immediately available when we first start. Just examining the idea of code, starting off really slow. Okay? So it's really important to understand that with an object-oriented language like C#, all of your code exists within a class. Let's go and talk about classes for a little bit. Okay, so we saw the line public class MyScript : mono behavior inside of the code that I just showed you. And C#, as I mentioned, is an object-oriented programming language. And that means that all code must lie within a class. It must be defined within a class. It all has to exist within a particular class. You can't write code outside of a class in order to use C#. A class will inherit or contain all the information about an object, so basically what it can do and what it is. If we look back at our public class MyScript : mono behavior, MyScript inherits all of the information, all of the data, all of the variables and the functionality from mono behavior. Afterwards, we can add additional information to MyScript to make it different than mono behavior. So MyScript inherits from mono behavior, but we can make it different by adding additional things to it. Now, those things are variables and functions. So let's take a quick look at an example. Let's say that we had let's look at it this way here. We have a vehicle, and everyone knows what a vehicle is, and we can define a function for a vehicle. All vehicles have the ability to steer, so it has a method for steering. Later on, I can suggest that we have a new object, a new class called car, and car inherits from vehicle. If car inherits from vehicle, and we then include additional information that a car has 4 wheels, well, the car itself has inherited the steering functionality from vehicle, but we've added a new functionality or new definition of it having 4 wheels. Similarly, if we created another class called plane, and plane also inherited from vehicle, well then plane would have the ability to steer, but we could also add additional functionality or variables. So we could say a plane can also fly. It has a method for flight. So in this case, both plane and car would inherit from vehicle. They both inherit the information from vehicle, but we've used additional attributes and functionality to define two new classes as well. Car and plane are not the same object. A car cannot fly, and a plane does not have four wheels. Okay? So a class has to contain all of the attributes and all of the functions that will define the object that you are creating. Anything that's not located within the inherited class or that's defined within the class itself will not be available to that particular object. Now, looking back at the code that we just recently saw inside of Visual Studio, we saw that the class had two brackets, curly brackets, braces, whatever it is you want to call it, had two of them that defined the scope or defined the area, I guess, of that particular class. Anything that falls outside of those curly braces, the external curly braces, anything that falls outside of those curly braces will not be considered as part of the class. They're not code associated with the class in any way. When we took a look at our particular class, our MyScript class, we noted that there were two functions, the start function and the update. Both of those were available to the class itself. Nothing else was associated with that particular class. We defined nothing else at all. Unity automatically, when we started this brand new C# script, Unity automatically created our start and our update for us, and it will always do that for you. So it's really important to note that anything that falls within the brackets are considered within the scope of that particular object. In this particular case, if we look at an example here, if we've got ourselves a class, we've got ourselves our external brackets, and within those external brackets, we see 3 lines of code, pseudocode. We see grapes, we see function 1, apples, we see function 2, pears. So what does this mean? This means that this particular class has several things that define it and that it can do. It has a variable called grapes, and grapes is a variable that is allowed to be used by anything, any of the functions that are here. It is within the scope of the entirety of the class. Function 1 has a variable called apples. Apples is only within scope of function 1. Function 2 cannot utilize apples. Function 2, within its scope, within its curly brackets, has a variable called pears. And again, pears is only within the scope of function 2. That means function 1 cannot use pears. Both function 1 and function 2, however, can use grapes. I don't know if that was confusing or not. Anyway, I'm hoping it's not. We're going to get used to this stuff. Right now, we're just looking at the idea of classes, and we're going to get used to this stuff as we move forward when we actually start coding. We're not actually coding yet, guys. Okay. Now, this is basically what I said. Grapes is defined in the class, so all functions in the class can access grapes. Apples is only defined in function 1, so only function 1 can use apples. Pears is only defined in function 2, so only function 2 can use pears. Grapes is within the scope of the class. Apples is within the scope of function 1. Pears is within the scope of function 2. Okay, so when we start to think about the idea of classes, we have to understand that the variables and the functions define precisely what a class can and cannot do. A class can only do the things that are described within the functions, and they're only described by the variables that are associated with that particular class. So if we take an example of a dog, we know a dog has 4 legs. Well, healthy dogs have 4 legs. 4 legs for a dog, a tail, and 2 ears. These are the things that make up the dog. If we think about the functions of the dog class, a dog can walk, a dog can run, and a dog can bark. These are the things that the dog can do. The dog is described by the variables, 4 legs, a tail, and 2 ears, and it is able to perform the functions of, or do, walk, run, and bark. It cannot do anything else that is outside of these ideas. Nothing else is defined for the particular dog class that I've described here. Okay, so that is a really brief, basic introduction to the idea of object-oriented programming and the idea of classes. We're going to get into this very, very thoroughly as we study classes in the rest of this particular course. As I've already mentioned, all of our code must be associated with a class. So you guys are going to see just how these things work firsthand as we move into practical exercises. All right, everyone. I hope that wasn't confusing. I know for a lot of people that this is going to be a stretch. For a lot of my artists, this might be a stretch for you guys, but we are going to get through it, I promise you. All right, guys? If you enjoyed it, let me know down below with a thumbs up. If you didn't like it, a thumbs down is perfectly fine. If you'd like something changed, give me a thumbs down and tell me what it is that you didn't like, and I will do my best to make sure that I've changed that in the future. These asynchronous videos are extremely important, and I want to make sure that I get them right. All right, guys? Thumbs up, thumbs down, comments down below, and if you haven't done so, please take a few seconds to subscribe. Have yourselves a wonderful day, everyone.